Okay, well, it's good to see everybody. Hope you had a good weekend. A few announcements before we go ahead and get started. So last week we took the second exam of the 9 weeks. So this coming Friday, which is the end of the first 9 weeks, by 8:05, that's the deadline. If anybody scored below an 80 and is interested in retaking that, you'll just have to turn in the sinusoidal applications assignment. Now, last Friday, I passed out a couple of papers. One was the assignment for the inverse trig functions. So we're going to wrap that up today and start the next lesson. So the homework is due on Wednesday. Key is already posted to the website, but we'll have a quiz over that on Thursday. So because it's the end of the 9 weeks, that quiz grade on Thursday, I'm going to carry that over into the second 9 weeks. So we're going to start with a grade right off the bat. And then the other paper you picked up was the extra credit. There were 7 problems. If you get 5 out of 7, you get 1 or 2 options. I've already had a lot turned in. But if you weren't here on Friday, remind me at the end of class. If you're interested, I'll go ahead and get you one of those. That's all the information I have, unless anybody had any questions about that. Sounds like a plan. Okay. Well, I believe it was Thursday. Maybe Thursday, maybe Wednesday. I know it was last week. I gave you this sheet with all these additional compositions. Okay, we still have the last 2. I want to look at these as kind of a review, and then we'll move on with our next lesson. So if you've misplaced this, unfortunately, I don't have any extra copies, but one of the papers that you picked up today that has the domain and ranges for all the inverse trig functions, that's a great scratch sheet of paper. Yeah, do you have your match? Okay, we get in here 11:05, so 11:10, so it's pretty close. All right, so we're going to do this last one first, and I'm going to have you try one on your own. So it says tangent of tangent inverse of 8.2. Okay, so when we're dealing with a composition of functions, remember we're working 2 functions back to back. The answer that I get for the inside function, I'm going to plug that directly into the outside function. That's how we continue through the composition to get our values like answer. Okay, so right now I'm not going to worry about tangent. I want to evaluate tangent inverse of 8.2. Tangent inverse of 8.2. Okay, remember tangent inverse can only be in quadrants 1 and 4. So what quadrant is this one in? Okay, it would have to be 1 because it's what? Positive. All right, so I'm going to go ahead and draw a triangle right here. So the answer to tangent inverse of 8.2 would be this angle theta. Remember, we always rotate from standard position to the hypotenuse of our triangle. Well, tangent is y over x. So we have a y, we have an x. Okay, so this is 8.2, this is 1. Now, I can use the Pythagorean theorem to go ahead and figure out what the length of the hypotenuse is, but because it's tangent, I only need the legs, so we don't actually have to do that extra work unless you just really want to. All right, so here's the thing, though. This triangle is not what? Now, what do you mean by perfect? Special. It's not a special right triangle. It's not a 45-45 or a 30-60, but the triangle still exists. I mean, we're going to be able to get some answer theta out of that. Now, here's the thing. If we wanted to measure it, we could go ahead and use technology, but this is one of those compositions we don't need to know that first answer in order to continue. Let's just say the tangent inverse of 8.2, it's just that angle theta. Now, we do know 2 things about this. Because it's in quadrant 1, it's not only positive, but it would be acute. Now, whether I end up knowing this value or not, where am I going to place it? Because right now I'm only halfway done. So how would I finish the problem? There you go. I'm going to take this answer from the inside function, and I'm going to plug it directly into the next function, the outside one. Okay, so I'm trying to evaluate tangent of theta. Okay, well, we already said previously that it's a positive acute angle, so that's going to put me in quadrant 1. So let's say I go ahead and draw this here. Let's say it gave me that angle. Now, just like we evaluate every other normal trig function, we use the sketch of the angle to create a right triangle. Now, if we're working a composition where I don't know what that first value is, I'm going to get my answer by saying these two triangles are what? Well, they are similar, but that's what allows me to do this. They're identical. They're exactly the same. So I'm just going to say, okay, it's going to have the same hypotenuse. It'll have the same height. It'll have the same base. And remember, tangent, it still wants y over x. So y 8.2 divided by the x1, this answer is 8.2. Now, this was a special type of composition. If I remember from the beginning of this packet, we briefly mentioned it last week. There were a bunch of composition rules where the input was the final answer, but there were restrictions on those. Okay, so remember I said if anybody was interested, you're more than welcome to look at them. I think it's probably better just to run through the problems because I think it gives you a better understanding of what it is we're doing. Okay. Any questions on that? Okay. Well, now that we've reviewed one, I want to give you a couple of minutes. Try the one right next to it. Evaluate tangent inverse of tangent of 3 pi over 5. And I'll go ahead and tell you on this one, the answer is not 3 pi over 5. Oh, goodness. A couple minutes. Yeah, that's okay. Do you see a scratch sheet of paper? Because I don't think I have any more copies of this one. If I do, I don't know where I placed them. Okay. Well, I'll give you another one. Yes. So you want some scratch paper? Yes, a few seconds. Okay, 1 minute. Okay, that is 2 minutes. Here's what you should be getting for your final answer. Negative 2/5 pi, or negative 2 pi over 5. Okay, how many people got that right? This one's been a tricky one today. Okay, let's go ahead and talk about it. So the first thing I want to do is evaluate tangent of 3/5 pi. So tangent of 3 pi over 5. Okay, so this isn't an inverse, so I have to go ahead and locate the quadrant that angle belongs in. So where would I find 3 pi over 5? Quadrant what? It is in quadrant 2. If you were to convert that to a degree measure, it's 108 degrees. Okay. There's also other ways to go ahead and figure that out, but let's say this is our angle here. So we rotated, this is 3 pi over 5. That's a 5 right there. Okay, so there's my angle. Now, just like we talked about a second ago, I'm going to use this angle to create a right triangle with the closest x-axis. Okay. So what's the reference angle created between the terminal side and the x-axis there? It would be 2/5 pi. Go. So this right here would be 2 pi over 5. And that makes sense because 3/5 pi plus 2/5 pi, there's the 1 full pi right there. Okay. Now, unfortunately, this is not a special right triangle like the previous one, but we know that the triangle exists. So there's got to be some base length x, some height y, and some r for the hypotenuse, right? So even though I don't know what this ratio is going to be, let's do just like we did on the previous problem. Let's just say that tangent of 3 pi over 5, that's y over x. Even though I don't know this value, that is perfectly fine. What am I going to do with y over x? Like when we didn't know theta, where'd I put it? There you go. We plugged it into the outside function, right? We're going to do the same thing here. So you're absolutely right. Plugging it into tangent inverse. So now over here, I'm going to have tangent inverse of that y over x. But there's one thing we know about that fraction. Should it be positive or negative? It should be negative because we're in quadrant 2. See, that's where x is negative and y is positive. So I know this is a negative. So that's going to help me continue this problem. Tangent inverse of a negative, so that means I'm going to place this in quadrant 4. Okay. Well, I'm going to use the same y, the same x. That would give me the same hypotenuse. Remember, we don't know what this value is, so we're going to say that these two triangles are identical. So what's the angle here directly across from y? That's 2 pi over 5. So I've got to rotate clockwise to get there. So that's why my answer would be negative, because we ultimately ended up in quadrant 4. Does that make a little more sense? Anybody have any questions on that? Yes, Lexi. Because we're in quadrant 4, remember we always rotate from standard position to the hypotenuse of our triangle. So because I had to rotate clockwise, we had a negative angle. Because we had tangent inverse of a negative ratio. See, we didn't know what y over x was. We just knew because of the placement of the original, it had to be a negative fraction. Is that good? Okay. Anybody get close? Okay. There are a lot of great practice problems on that assignment you got last Friday, so I would absolutely encourage you to take a look at it. In fact, tomorrow, it's not going to take us the entire period to finish up this next lesson, so we'll go ahead and start looking at the assignment early. Okay, so let's go ahead and put this to the side. And let's pull out this paper right here. Okay, so I'm going to introduce the remaining inverse trig functions. Now, the top 3 rows of this table is hopefully going to look familiar. This is the domain and range, the input restrictions for sine inverse, cosine inverse, and tangent inverse. So those we've already been talking about for a week now. I went ahead and gave you that little cheat sheet that had the little colored circles on there. What we want to look at today are the remaining inverse trig functions. Cosecant inverse, secant inverse, cotangent inverse. Now, before I forget, if you look at the second to last row, the secant inverse range, this bracket right here needs to be a parentheses. And in the very last row, the range for cotangent inverse, instead of 0 to infinity, it should be 0 to pi. Those were 2 little typos we need to fix on the notes. Okay. But this is the intervals that your ratios have to be for the input. These intervals we have for the range, those are where your answers are going to be coming from. So, for example, cosecant inverse, it's got to be from negative infinity to negative 1 or from 1 to infinity. So anything in between negative 1 and 1 is going to make cosecant inverse undefined. Our answers are going to be between negative pi over 2 and pi over 2. So just like sine inverse, cosecant inverse is restricted to quadrants 1 and 4. But with one big difference, you'll notice right here in the middle, 0 is not included because it's undefined at that location. And then you can take a look for secant of inverse, cotangent of inverse. Normally in the past, I would go ahead and show the graphs, just like we did last week. We'd restrict their domain, invert them. But I thought, let's just get on with it. You're not going to be tested on that part of the concept for the AP exams. You're good. So secant inverse can only be in quadrants 1 and 2. And then cotangent inverse is going to be restricted to quadrants 1 and 2 as well. And actually, that's going to play a big part in what we're about to do. Did everybody have the opportunity to jot that down, or do I need to leave it there for a second? I take that as yes. Okay, well, let's see here. How are we going to evaluate these new inverse trig functions? Well, there's quite a few ways to do it. We're going to go ahead and use the reciprocal. Let's say I want to evaluate secant inverse of x. Well, what I'm going to do is take the reciprocal of the trig function and your ratio. So secant inverse of x is going to become cosine inverse of 1 over x. And see, now it's a problem we're already accustomed to solving. Okay, we're just going to get a little more practice. If I want to evaluate a cosecant inverse of x, I'm going to rewrite it as sine inverse of 1 over x. Okay, we already know how to solve those. Now, the only one you got to be careful of is going to be cotangent inverse. Okay, so we've got 3 possibilities based on whether your x, your ratio is going to be positive, negative, or 0. Okay, so if x is positive, well then you'll rewrite it as tangent inverse of 1 over x. You'll simplify, everything's good. But if it's cotangent inverse of a negative ratio, if that ratio is negative, you still take the reciprocals, but you have to add pi. Okay, so here's why. Tangent inverse of a negative, what quadrant would that be in? 1 or 4? 4, right? But if you come back over here, we just saw that cotangent inverse can only be in quadrants 1 and 2. So if tangent inverse with that negative puts me in quadrant 4, we have to add pi to get me back in the correct quadrant. So that's why we have that there. So if it's a negative, we got to add pi. And then this is the one that's going to be nice. If it's cotangent inverse of 0, you don't have to do anything. The answer is pi over 2. Okay. And then the second column over here, this is just introducing a new notation. So if I were to take the word arc, A-R-C, simply place that in front of a trig function, that means inverse. It's just another way of writing it. So if I had sine inverse of x right here, that equals arc sine of x. Okay, so arc is just going to mean inverse for us. Okay. All right, well, let's try some problems. Let's see what we got here. So A, we want to evaluate arc cosecant of 2. Okay. Right, Carolina? Right. Okay. So somebody help me out. What's the reciprocal of cosecant? Sine. So this arc cosecant of 2, I'm going to first rewrite it as arc sine of 1/2. Remember, we're taking the reciprocal of the trig function and the ratio. Right, Mason? Okay. Now, if you're not a big fan of that new notation with the arc, you can always go back to what we had previously. You could say sine inverse of 1/2. There's no difference. It still just means inverse. Okay. All right, well, let's see here. Noah, sine inverse of a positive, 1 or 4? 1. Okay. So I'm going to go ahead and draw a triangle right here. So this angle theta, remember when I rotate from standard position to the hypotenuse? That's the answer I'm looking for. Okay. Well, what side lengths do I know for this triangle here? There we go. Remember, sine is y divided by r. So I know the height is 1. I know the hypotenuse is 2. What's the other leg? It is root 3. Does anybody want me to run through Pythagorean theorem? Okay. So what type of triangle is this? So 30, 60, 90. So what's the answer I want? 30 or 60? Now, why would I choose 30 instead of 60? There you go. The smallest angle has to be opposite the shortest side. Okay, so what is arc cosecant of 2? Well, that's going to be 30 degrees. But remember, these problems that end up with a special right triangle, you want to write your final answer as a radian. So this is pi over 6. There you go. So we're solving these new inverses by just continuing to practice what we did before. Okay. Any issues, any problems, any questions? Easy, right? Okay. Well, let's try another one. How about secant inverse of a negative root 2? So what was the reciprocal again of secant? Cosine. So I'm going to go ahead and say cosine inverse of, well, the reciprocal would be negative 1 over square root of 2. Notice anything? There we go. Up until now, every time we've seen something like that, we've rationalized because we don't like a radical in the denominator. This is one of those rare occasions you don't have to rationalize. I could go ahead and say that the x value is -1. I can say that the hypotenuse is √2, and I'm going to be able to get the right answer. If you want to rationalize, you're still going to be able to get the right answer. It is up to you. Does anybody want me to change it or leave it as is? Leave it? Okay. Well, we have cosine inverse of a negative. Where am I going? 1 or 2? 2. Okay. So that's already telling me that my answer's got to be what? What's that O word? Oh, not negative. Cosine inverse cannot give me a negative. But it can give me an obtuse. There we go. Okay. So I'm going to go ahead and draw this triangle right here. Okay. Let's see. The x is -1. The hypotenuse is √2. What would the other leg be? Peyton? Not quite. It would be 1. Here we go. Again, anybody want me to run through Pythagorean theorem? Okay. What type of triangle is this? 45, 45, 90. Yeah. So does that mean secant inverse of -√2 is 45 degrees? Why not? That's my angle. What am I missing? Remember, we always rotate from what? Standard position. So if this angle is 45 degrees, how far did I rotate to get that reference angle? 135 degrees, which is, what is a radian? Oh, don't want to forget the unit circle. 3 pi over 4. There we go. How are we doing? Okay. You're probably thinking to yourself, Mr. West, this is too easy. I want to try one on my own. Okay. Who said no? All right, let's try C. All right. Cotangent inverse of a -√3. Okay, so let's say I'm a minute for this one. Okay. Now remember, this is cotangent inverse, so you might want to look at the top of your page. Be careful which of the 3 options are you taking. Because we evaluate cotangent inverse based on whether that ratio is positive, negative, or 0. It's going to be an interesting week. Does everybody know that you have another 3-day weekend coming up? So you don't come to school on Friday. Or I mean on Monday. Friday you come to school, okay? But on Friday, what's happening during this class? We got the pep rally. Why are they doing the pep rally? The game isn't until 7, right? Anybody know why? Okay. But all I know is we're bringing home the Spurs, right? I said, no, come on. We even got football players in here. They're going to be like, yes, we can do it. Okay. All right, here we go. I can motivate you to learn, and I can motivate you to bring home the Spurs. There. So, is everybody ready? Here's what you should have gotten. Cotangent inverse of a -√3 is 5 pi over 6. How many people got that right? Okay. All right, well, let's go ahead and talk about it. Okay. So cotangent inverse of a -√3, first thing I'm going to do is rewrite it. So this is tangent inverse of a -1 over square root of 3. I can't help but feel I'm forgetting something. Yes. Okay, this is what I was referring to. Remember, if it's cotangent inverse of a negative, you've got to add pi to whatever you get from the reciprocal. Okay. So we can go ahead and rationalize this if we want to. I'm not worried about it. So we'll take care of that plus pi last. Tangent inverse of a negative, well, that's going to be quadrant 4. So here's the angle theta that I'm looking for. Let's see, we're going to use this y and this x. So this would be -1. This is square root of 3. Excuse me. What's the hypotenuse? 2. Again, anybody want me to show Pythagorean there? Okay. So this is a 30, 60, 90. Again, this one would again be 30 because of the reasons we talked about previously. Now, it would be negative. So negative 30 degrees is a negative pi over 6. But don't forget, we have to add pi. Okay, because cotangent inverse can only be in quadrants 1 and 2. But this tangent inverse reciprocal put me in quadrant 4. So that pi is going to put me in the correct place. So if I were to go ahead and do that, that's where the 5 pi over 6 comes from. In fact, did anybody want me to run through the algebra? Yes? Okay. So let's say I have a negative pi over 6, and I'm going to add the pi over 1. Well, my common denominator would be 6. So this is going to give me a negative pi over 6 plus 6 pi over 6. We're going to keep that same denominator, but a negative pi plus 6 pi, there's my 5 pi. Okay. Question. Not too bad. Well, all right. We'll go ahead and take this off. So now you're probably thinking, well, Mr. West, I'd like to come up and show my peers how much I know about this subject. Okay. So I was like, oh, arc cotangent of 1. Let me give you a few seconds to think about that. And then we're going to use the wheel of destiny. Right, Rami? Right, Carolina? Right. So in here, we got to get to seat number 32. Okay, let's see here. So let's sort this out. 31, 32. Okay, let's give this a good shuffle. Don't you want to wait until I spin the wheel? Do you have your badge? Okay. Wouldn't that be crazy if number 30 came up? Oh, that was close. Okay. All right. Fortunately, I got to spin this again. That's okay. Don't worry about that. Okay. 22. Weston. All right. Weston. Weston, Wheel of Destiny has chosen you. Yes, sir, please. Yes. You're going to walk us through this problem. Arc cotangent of 1. So am I going to have to add pi on this one? Why not? We added pi on the previous cotangent. What's the difference? Okay. Only if it's cotangent inverse of a negative will you add pi. Okay. So let's see here. So this is tangent inverse of 1 over 1. Okay, perfect. Yeah. So the triangle is in quadrant 1, okay. Okay, we got y and x. There's something we got to do to that too. Yes, there we go. Perfect. What kind of triangle is that? Okay. So what's arc cotangent of 1? Uh-huh. You just told me.
I just told you.
Mm-hmm. Oh, you said something after that.
Oh, yeah, 45.
45.
Pi over 4.
Pi over 4. There we go. That's it. All there is to it. Good job. That's okay. We'll leave that there. Oh, okay. We can do that too. There you go. Harrison.
supposed to be using the formula? Or?
No, that one's a special case. We're not worried about that. Or in fact, if you want to talk about it later, we can, but it's not going to come up for us. Okay, cool, cool, cool. All right, well, let's take a look at that other side here. Okay, finding approximate values. So this is where the ruler and the protractor are going to come back again. So a little more practice on this. Number 3 says find the value of arc secant of a -3/2. Okay. So first off, reciprocal of secant, cosine. So this is going to be arc cosine of a -2/3. All right, so let me go ahead and sketch out the triangle that we're going to need. It's cosine inverse of a negative, so that's quadrant what? 2. Okay. So I'm going to go ahead and draw a triangle right here. Okay. We're going to use this x and this r. So the base here is -2. The hypotenuse is 3. Can anybody tell me what the other leg is? It's not 1. It is a radical. Square root of, oops, someone said it. 5. Square root of 5. Did anybody want me to run through that? Okay, let's actually do this. So let's say I don't know what that is. Let's call this a. Okay, so we'll have a squared plus b squared, so that's a -2 squared, is equal to c squared. So -2 squared, that would be 4. Okay, it's equal to 3 squared, 9. So a squared is equal to 5 when I subtract the 4. And since we're looking for a, we're going to take the square root. Okay. Now, what we notice about this, the triangle is not what? It's not special. So I don't immediately know this angle so that when I rotate, I can get my answer. Okay, so we're going to have to recreate this triangle in the second quadrant. Now, my, again, suggestion is to measure using centimeters. You're more than welcome to use inches if you want to. Now, for this one, because we have a radical expression, we're probably going to want to rewrite that. I can't talk today. We're going to want to rewrite that in millimeters. Okay, now because we don't have the calculators out today, I'm going to help you out. So the square root of 5 is about 2.24. Let me turn on the light, so this is going to be easier for you to see. Okay. So as you're working along, I'm going to do the same thing. So I need a base length of 2 centimeters. Okay, so let's say right there. And 2.24 centimeters would be 22.4 millimeters. Okay, so let me get this, if this move just a little bit more. There we go. Okay. So here's 10, 20, 22.4, maybe right about there. Okay. Now, you're welcome to recreate the entire triangle, but you only have to draw the hypotenuse. So from the origin, I'm going to go through that point that I made. I'm going to make my hypotenuse much longer than it needs to be, just so it's easier to read my protractor. Okay. All right, well, let's see how I did here. We'll go ahead and take that off. We'll put my crosshairs right there on the origin. Okay. So looks like mine is about maybe 133, 134. Okay. What are you folks getting? 130 what? Okay. 34? Noah, what'd you get? Okay. Now let's see how well it did. If you put this in the calculator, here's what the actual answer is, 131.8. So even mine was slightly off, and that's okay though. That's okay. Now here's the big question. Is there anybody who was way off? Anybody need help measuring? So let's see here. All right, so here's some pencil. So we're going to go ahead and start with See, we got the 2 centimeters. Okay. So I'm going to go ahead, make a mark right here. And then from there, I'm going to go up. So here's 10, 20, 1, 2.4. Let's say it's right about there. So we want to go ahead and measure this from the origin through that point. Pretend I hit that point.
You did not hit
I did not hit that point. But you're going to put that little circle right there, right on your origin. And you're going to line it up. There we go.
Oh, I got like a...
Yeah, so there we go.
I got 130.
Good, good. Okay, anybody else? Okay. Oh, yeah, no, you have your batch? All right, well, let's go ahead and try this last one here. Cotangent inverse of a 1/2. This will be our last problem for today. Let me go ahead and get this all set up again. Okay. All right. So how about we have somebody come on up here and help me out with this one as well. Now, you go ahead and get me started. I'll just have somebody come up here and measure. So let's see. How should I rewrite cotangent inverse of 1/2? Oh. Just 2? Or you want to put it 2 over 1? Okay. So cotangent inverse of 1/2, that's going to be tangent inverse of 2 over 1. Okay. Let me get this out of the way. So it's tangent inverse of a positive, so that means I'm going to go right here in the first quadrant. We have y divided by x, so this is 2, this is 1. If you use the Pythagorean theorem, you're going to get that to be the square root of 5. Okay. But we actually don't need that because your legs are perfect. We don't have to change these to millimeters. We can just measure a base of 1 centimeter and a height of 2 centimeters and go ahead and measure that. Okay. So who wants to come on up and measure out this triangle for me? Okay. Oliver, okay. Because Mason, you were volunteered. Who do you think volunteered you? Oh, okay. Okay. All right, but we had a volunteer. All right. So let's go ahead and hit this right here. Okay. Oh, remember we got to start that from the origin. Okay. So let's say 1 centimeter is right there. Okay. Let's go ahead and get that out of the way. And here is that one, sir. There we go. Now we want to go up 2 from there. Okay. Let's get that out of the way. And if you use this, okay, you can start at the origin. You'll draw a straight line through that point. There we go. And now all we got to do is move that protractor down. Okay, so it looks like Oliver, just a D right there. What would you say his measurement is? 67? I might say somewhere around 62. Oh, you got 63. Perfect. Okay. In fact, when you round it, if you put it in the calculator, you're going to get right about 62 degrees. So that is perfect. Good job. Good job. Okay. How are we doing? Hey. Well, fantastic. So, like I said, we are going to be finishing up right now. If you want to go ahead and get those rulers and protractors up to the front. Okay. Now, we don't have a lot of time left, but if you wanted to go ahead, take a look at the assignment. Remember, with the time we do have left, unfortunately, we can't get out the cell phones or the earbuds. You folks have always done a great job about that, but I just need to go ahead and remind you.